In a muddy river that looks almost black, something the width of a human torso slides beneath the surface. No fins, no limbs, just a long, muscular body pushing water aside like a slow-moving landslide. Then it rises. A head the size of a motorcycle helmet breaks the surface for a second, and the water around it trembles. This is Titanoboa, a snake so long that if you stretched it across a road, it would reach from one end of a city block to the other. And not just long, heavy, not big for a snake, big in a way that makes the physics of being a snake start to collapse. Because when an animal gets this large, nature does not just ask, can you kill? It asks, can you move, can you breathe, can you keep your body from overheating, can you crush something without crushing yourself? Titanoboa lived around 60 million years ago in the Paleocene, in what is now Colombia. Fossils suggest an animal roughly 12 to 15 meters long, with a mass that may have reached well over a ton, depending on the estimate. To picture that, imagine an anaconda. Then imagine stacking several anacondas end to end, and turning the entire animal into something denser, thicker, and heavier. At this scale, snake stops being a normal design. A snake's body is basically a continuous tube of muscle and ribs. It has no legs to lift itself, no rigid skeleton to support a towering frame. On land, length becomes friction. Mass becomes burden. Every meter you add makes turning harder, moving slower, and cooling more difficult. And Titanoboa wasn't built for sprinting or chasing. It was built for something else. A world of warm, flooded forests, swamps, rivers the color of coffee, water thick with silt where visibility collapses to almost nothing, a place where the surface is calm and the danger is underneath. But even that environment raises a bigger question. Because Titanoboa did not evolve on a normal Earth. It evolved in a planet state that barely exists anymore. The Paleocene was hotter and more humid. There was no polar ice like we know it. That matters because Titanoboa was not a warm-blooded predator, it was a reptile. Its body temperature was shaped by the world around it. Reptiles follow a strange rule that mammals do not. When the environment stays hotter for long periods, a cold-blooded animal can grow larger, because its metabolism can run faster without the constant risk of freezing, slowing down, or failing. Heat does not just make a reptile more active. It changes the upper limit of what its body can sustain. This is the first uncomfortable idea behind Titanoboa. It was not just a monster. It was a consequence. A biological answer to a planet that had shifted the rules. So Titanoboa did not break biology. Biology broke differently because the world was different. And that leads to the real mystery. If Titanoboa was possible only because Earth was hotter, then Titanoboa is not just a fossil, it is a measurement. A reminder that the planet can write bodies into existence and erase them again just by changing the temperature a few degrees. But to understand how Titanoboa actually lived, we have to picture its hunting world, because it did not hunt like a normal predator. It hunted like gravity. And once you see how it attacked, the size stops being impressive and starts being disturbing. Titanoboa did not need speed. It did not need pursuit. Because in the flooded forests of the Paleocene, movement itself was different. The world was not dry ground. It was waterlogged land, swamps that never drained, rivers that spilled into forests, shallow channels where the boundary between land and water barely existed. And in that environment, a snake of impossible size becomes something else entirely. Not a hunter running after prey, but an ambush you cannot see coming. Imagine standing near the edge of a dark river. The surface looks still. Maybe you see floating plants, maybe you hear insects. But beneath that calm, a body heavier than a car is resting almost motionless in the mud. Titanoboa's shape disappears in the water. Its skin does not reflect light like scales in a desert. It becomes part of the river itself. And then the strike is not a chase. It is an eruption. A sudden upward surge, a massive muscle accelerating out of concealment. At this scale, Titanoboa does not feel like an animal. It feels like a geological event with intent. because his prey was not small. This ecosystem contained giant turtles, large crocodile-like reptiles, animals already built like armored machines. And Titanoboa did not overcome them with venom. It overcame them with physics. Constriction is often misunderstood as simple squeezing, but constriction is not just pressure, it is system failure. A snake wraps around a body and each breath becomes impossible. Blood flow collapses, the heart cannot pump against the force. Organs begin to shut down. In modern boas this happens quickly, but with Titanoboa, scale changes everything. A coil the width of a human chest, muscle thick enough to deform bone, not crushing like a cartoon, but compressing the body until biology cannot continue. And here we reach the 230 decibel moment of Titanoboa. A snake this large is not simply stronger, it is operating in a different category of force. A normal constrictor ends an animal. Titanoboa could end an entire system in seconds. Not because it was evil, because size turns anatomy into inevitability. This creates another paradox. A body this massive generates problems as well as power. Muscle produces heat. A reptile cannot sweat. A snake cannot pant like a dog. So how does a 1-ton serpent avoid overheating? The answer is that Titanoboa's world was not just warm, it was stable. Constant humidity, water everywhere, a living coolant. Titanoboa was not designed for open land. It was designed for rivers and swamps where its own body could sink into temperature control. Even its hunting strategy reflects this. Water supports weight. Water hides movement. Water allows a giant animal to exist without collapsing under itself. Titanoboa was not an anaconda scaled up by accident. It was a solution built for a specific environment, and that environment shaped every rule of its existence. But we did not discover Titanoboa by watching it hunt. We discovered it from fragments, a few bones, a handful of vertebrae. And from those pieces, we reconstructed an animal that should not have been possible. Which raises the next question. How do you rebuild a monster from almost nothing? And how sure are we that we understand what we found? Titanoboa feels like something invented. A myth scaled too far. A serpent so large it stopped sounding biological. And yet we did not find it as a complete skeleton. We found it the way deep time usually reveals its secrets in pieces and fragments, in bones scattered through ancient sediment. The discovery began in Colombia, in the Cerrejón coal mine. A place that today is dry and industrial, but once was a tropical swamp forest. 58 million years ago, this was a world of heat, mud, and slow rivers. And buried inside it were vertebrae unlike anything living today. Enormous spinal bones, thick, heavy, too large to belong to any known snake. And this is where the scientific process becomes part of the mystery, because you cannot measure Titanoboa directly. You cannot watch it move, you cannot confirm its behavior. You have to infer an animal from structure. So how do we know it was a snake at all? Because vertebrae carry signatures. The shape of the joints, the way the ribs attach, the proportions of the spinal canal. These bones do not match crocodiles, they do not match lizards, they match serpents taken to an extreme. Researchers compared these vertebrae to modern boas and anacondas, and a pattern emerged. In snakes, vertebra size correlates strongly with total body length. A bigger spine means a longer animal. So from a handful of bones, estimates began to form. 12 meters, 13, 15, a creature longer than a bus, and possibly weighing more than a ton. But even here, uncertainty remains. Titanoboa is not a single number. It is a range, a probability. A reconstruction based on the rules of living snakes applied to a world that no longer exists, which means Titanoboa is both real and partially invisible. We know it lived, we know it was enormous, but we do not know its exact limits. And that uncertainty matters because it reminds us that paleontology is not the study of monsters. It is the study of evidence under constraints. We are not seeing the animal, we are seeing the shadow. It left in stone. And from that shadow we ask a deeper question. What kind of planet allows a snake to reach this size? This brings us back to the Paleocene. A greenhouse Earth, no polar ice, tropical conditions extending far beyond the equator, warm oceans, hot forests, the entire planet operating under different thermal rules, And reptiles respond to heat in a way mammals cannot. A mammal generates its own warmth. A reptile borrows it. So in a hotter world, reptiles can grow larger because the environment pays the metabolic cost. Titanoboa may not have been an evolutionary freak. It may have been a logical consequence. A snake body pushed to the edge because the planet itself made the edge possible. Which reframes the animal completely. Titanoboa was not just big. It was a climate signal, a biological measurement of how hot Earth once was. Its body was a thermometer, written in muscle and bone. And that is unsettling, because it means Titanoboa was not an accident. It was a temporary agreement between biology and environment, a contract, and contracts can be broken. The planet changes, the rules shift, and what was once possible becomes impossible again. So the question is no longer just, how did Titanoboa exist? The question becomes, why did it stop? Titanoboa did not disappear because it was defeated. It did not vanish because something stronger arrived. It ended because the world that made it possible began to fade. The Paleocene was not permanent. Earth does not hold still. Temperatures shift. Forests change. Rivers reroute. And slowly, the greenhouse conditions that allowed reptiles to grow enormous began to cool. Not overnight, not catastrophically, but enough. Enough that the contract was broken. Because Titanoboa's size was not just power, it was dependence. A body that massive requires a certain thermal background, a certain stability, a certain world. In a hotter planet, a cold-blooded giant can function. Its muscles remain active, its digestion works efficiently, its metabolism stays within viable limits. But as temperatures drop, the same body becomes a burden. Movement slows, energy costs rise, hunting becomes harder. And gigantism stops being an advantage. This is the hidden fragility of extreme designs. Titanoboa was not built for flexibility. It was built for a specific Earth. And when Earth changed, the animal no longer fit. The prey changed too. Wetlands shifted, vegetation transformed, and different species filled the ecosystem. And Titanoboa's world became less predictable, less warm, less suited to a serpent that large. Evolution does not create final monsters. It creates solutions, temporary solutions for temporary rules. Titanoboa was one of those solutions, a masterpiece of constraint, a snake shaped by physics, climate, and opportunity, and then erased when those variables moved. Which leads to the deeper point. Titanoboa feels impossible to us because our planet today does not allow it. Our forests are not that hot. Our wetlands do not sustain that same structure. Our climate does not write the same biological permissions. So Titanoboa becomes a myth in hindsight, not because it was unreal, but because the rules that produced it no longer exist. And that is the unsettling lesson. Nature does not have a fixed catalog. It has a rule book, and when the rule book changes, the shapes of life change with it. Titanoboa is proof that normal is conditional, that impossibility is contextual, that the limits we assume are often just the limits of our current environment. There is a time when a snake the weight of a car was not absurd. It was simply what the planet allowed. And the most uncomfortable question is not, could Titanoboas exist again? The question is, what other Titanoboas have existed under other versions of Earth that we will never imagine because we have never lived under their rules? Because somewhere in deep time, the planet has already written creatures that would seem fictional to us now. Not monsters, not anomalies, just biology, obeying a different set of conditions. Titanoboa was not a mistake. It was a contract with a hotter Earth. And the moment that Earth cooled, the contract ended. If you want to keep exploring the places where nature stops feeling familiar, where biology begins to look like something else entirely, then you already know what this channel is really about. Because the deeper we look into the past, or into environments we rarely touch, the clearer it becomes that normal is only a surface rule. When you look at Titanoboa, it's easy to think that the horror is in the scale. A snake the length of a bus, heavier than a car, turning the forest floor into a moving trap. But the real discomfort is realizing that even this made sense. Given enough heat, enough prey, in the right swamp, a 1-ton serpent is not a monster. It is just what the equations allow. And if that is true, then the question shifts. If you do not have the luxury of a massive body, how far can evolution distort the blueprint of a predator instead? Because the strangest designs are not always the biggest. They are the ones that look fragile, almost harmless, 8 thin legs, a soft body, and then you zoom in. Legs that move on liquid pressure instead of muscle. Silk that, gram for gram, outperforms steel. Venom written like a chemical program, tuned to flip specific switches in nerves, blood, or breathing. Titanoboa shows you how far size can be pushed before the planet says enough. Spiders show you something different. How alien a predator can become when nature stops scaling things up and starts rewriting the rules of what a predator is.